Okay, in this video I'm going to do a proof of the rule for the first principles. So what I've drawn here is some kind of a curve, and what I want to do is I want to calculate the rate of change between these 2 points. Now the idea behind first principles is that we want to calculate an instantaneous rate of change. So really we want the difference between these points to be nothing, okay? But we're going to just work it out as we would anyway. So if I wanted to calculate the average rate of change, I would join them with a dotted line and I would calculate the rise over the run. These 2 points, I haven't labelled any values here, so I might call this first point here the x coordinate, call it x, and the other one, I'll just call it x plus something h. So this is x and then this is x plus a tiny little bit. And well, the y value for this would be given by f of x, because we get the y value by subbing x into the equation, whatever the equation happens to be. And the y value for this point here would be given by f of x plus h, because when we sub x plus h into the equation, we get that y coordinate. And now I can calculate the rise and the run, because the rise is the difference between these two values, and the run is the difference between these two values. So I'm just going to write m equals rise over run. So this really is going back to things that you were learning several years ago. But the rise in this case would be f of x plus h minus f of x, as I said, the difference between those two values, and that will be over the run, which is going to be x plus h minus x. So lastly, that can be simplified a little bit to become f of x plus h minus f of x. The x's will cancel each other out to just leave h in the denominator. Now this is part of the rule, okay? You might remember I said back at the start, we're looking for an instantaneous rate of change. So we want this difference here to be essentially nothing, okay? And this is where our limits become important. So what I'm going to say is we're going to make it so that we can see what happens as that difference is made nothing. So we're going to use the limit as h approaches 0, okay, because we want to know what is as that is becoming nothing of all this mess. Oh. And there we have it. So that is our rule for first principles. Now, there's a couple of things that I might sort of change here. So firstly, that is that we write the derivative of f of x as f dash x. So f dash x is equal to the limit is blah 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 blah. As you can see, this here really is just a bit of a fancy way of saying rise over run. And you can probably imagine that there might be some problems here, like with h approaching 0, we couldn't just make that simple substitution in here because we'd be dividing by 0, which would give us undefined in our answer. And in the next video you will see how we can sort of work around that, because yeah, at the moment it's just not all that nice. So anyway, we'll leave that there and yeah, get into some differentiation by first principles in the next video. See you later.